Okay, so next we are going to review a few special case factoring rules, difference of squares, sum of cubes, and difference of cubes. Okay, so the difference of squares is kind of a factoring shortcut. It says that if we have two perfect squares, for example, x squared and 49, and they're being subtracted, that we can use this handy little factoring shortcut where that just factors into this. You take the square root of the first term, so the square root of x squared is x. Square root of 49, second term, is 7. And then one gets a plus and the other gets a minus. And that's it. That's all you have to do. Square root of the front, square root of the back, a plus and a minus. And you can check that just by foiling it back together. X times x is x squared. X times negative 7x. Then we would have plus 7x. Then we would have minus 49. And the minus 7x and the plus 7x would cancel, giving us just x squared minus 49, which, pen is not playing nice. 49, which checks out. That's what we started with. Okay, just keep in mind, anytime you're doing anything with factoring, you always want to really quickly check for GCF at first. So before you dive into taking difference of squares for this 4x squared minus 64, you first want to factor out a GCF. So that's going to be 4, leaving you with x squared minus 16. Then that x squared minus 16 is a difference of squares, so we keep going with our two binomials. Square root of the front, square root of the back. One gets a plus and the other gets a minus. And that's it. It's just a handy little shortcut. It does not work for sums. There's a reason it's called difference of squares. Okay, so this x squared plus 16 down here on the bottom left does not factor. That's as simple as that gets. And then the 2x squared minus 36 over here on the bottom right, we can factor out a GCF of 2. X squared minus 18. And then we get 18, which is not a perfect square. So we stop with that term and leave it just like that. So that one's not a difference of squares either. Even though it has a 36 at the beginning, there's that 2 in front of the x squared, so you have to take out the GCF first, and then it's not a square anymore. When we get to cubes, it does work with sums as well as with differences. And the two rules, I've lined them up here vertically so you can see that they're very similar. They both give you a binomial and then a trinomial, where the terms are basically the same, but what is different is the signs. So to help you remember, if you think of both of these rules together, you just have to think of all the terms and then notice what's happening to the signs. So we've got the sum on top here, and notice that the sign matches in that first binomial. And then we have the opposite sign next. And then on the bottom, when it's a minus, there's a minus first. And then we have the opposite sign after that. And notice that the b squared on both of them is positive. So we've got a little mnemonic to help us remember this, and it's SOAP. So what that stands for, the S is for same. So the sign is the same as whatever you have in the original binomial that you're factoring. Then whatever the opposite of that sign is comes in front of the AB, and then the last term is always positive. So same, opposite, always positive, SOAP. Just a fun little mnemonic to make that a little easier to remember. So let's practice with one of these right quick. Here I've got x to the 6 plus 8. Okay, so x to the 6 is a cube, even though it's not exactly x to the third. 6 can be divided by 3. So its cube root is going to be x squared. The cube root of 8 is 2, because 2 times 2 times 2 is 8. So to factor this, we're going to say that we've got a plus b, so a and b in all of this is just the cube roots respectively of the front and the back, just like we had the square roots when we were doing difference of squares. So we're going to start with s, so same sign, so we're going to have x squared plus 2, and then it becomes a squared, so that's x squared squared, so that's x to the 4th. Then we have the opposite sign, SO, so minus now. A times b, that's going to be 2x squared. And then the last sign is always positive. So plus 2 squared is 4. And that is factored. And you can multiply those back together. You can distribute the x squared and then distribute the 2 and check that. Let's go ahead and do that just to be thorough. So if we distribute the x squared, we get x squared times x to the 4th. So we'll have x to the 6th. Distribute it to the minus 2x squared, you get minus 2x to the 4th. Distribute it then here, we get plus 4x squared. Then we distribute the 2, we get plus 2x to the 4th. You can see where this is going, stuff starts canceling out. Then you get minus 4x squared, voila, cancellation. And then you get plus 2 times 4 is 8. So those x to the 4th terms cancel out, the x squared terms cancel out, and you're just left with x to the 6th plus 8, which is where we started. So that is factored. So moral of the story here, you need to remember difference of squares is really easy to remember. But make sure that you know the sum and difference of cube rules, because we will be seeing this kind of randomly throughout the course. You may see it on the exam. But just remember the rule. If you don't remember it, consider it a TTK.